expression, and they would just say simplify. And it was maybe like a little bit ambiguous what simplify meant sometimes. It was kind of just get rid of fractions if you can, try and put things together into one expression if you can. Today it's a little bit different. They're going to tell you what the trig identity is. So they're going to say something like, we know that cosine squared times secant squared divided by sine squared plus cosine squared is equal to 1. And what you need to do is verify it. And basically, what does that mean? So you use your trig identities, you use all the tools that we developed the past couple days, adding fractions and factoring and simplifying and using your identities to go from here to here. So it's the same process, it's just they tell you what the solution is, they want you to show it. So why don't you start on that first one? Start here, let's look at cosine squared secant squared divided by sine squared cosine squared, and use everything that we've been doing the past couple days and try and get from here to here. So let's come together and go over this one really quick. How did you start? Top or bottom, numerator, denominator. Where do you start at? Denominator? Okay, so what do you want to do down there?
So change it to 1.
Okay, right. So we know that sine squared plus cosine squared is just equal to 1. That's our basic Pythagorean identity, so we can just replace it with 1. What are you going to do in the top? How are you going to deal with that? What identities do you know that'll help you simplify that?
Secant is the reciprocal of cosine.
Yeah, secant is the reciprocal of cosine. So you can just rewrite secant squared as 1 over cosine squared. You have cosine squared times 1 over cosine squared, cancels, cancels, and all you're left with is just 1. So that one's pretty simple. You just needed 2 identities. These get a little bit more complicated as you go on, but again, the basic idea is the same. You start on one side, you use your identities, use all the things we've learned, and you try and make it equal to the other side. You're verifying that identity is true. So on that next slide in your notes, we didn't copy this page out of your book, but it is on page 380. It's just guidelines for verifying identities, so it's just kind of general procedures to follow. And you don't need to write these down, but if you're having troubles when you're doing your homework, this is a good page to reference because it kind of tells you, here's what you do anytime you want to verify an identity. And kind of the first thing you do is you want to work with one side of the equation at a time, and it's better to work with the more complicated side first. So like on that last one, you didn't want to start with 1 and try and get from 1 to cosine squared secant squared over sine squared plus cosine squared. It would have been really, really difficult to know what you multiply by, what you do. So it's better to start with the complicated side. The second thing is looking for opportunities to factor, add fractions, square a binomial, or create a monomial denominator. That's just everything we were doing the past 2 days. We kind of had like those 4 different types of problems we looked at. Third thing, looking for opportunities to use identities. That's pretty obvious. And 4 is if the preceding guidelines do not help, try converting all items to sines and cosines. So like if you have tons of tangents or you have lots of cotangents and stuff, break them up into sines and cosines, and that generally helps. And 5 is probably the most important one. It's just always try something. If you're looking at one of these problems it wants you to verify and you don't know where to start, just start by doing something. Generally, if you finagle with a problem enough, if you just use your identities enough, factor enough, eventually everything is just going to work out. So we just have a couple more example problems, and it wants you to verify this identity. Where would you start with this one? What's the problem?
You have to get the same denominator.
Yeah, so you have 2 fractions you want to add. They have different denominators. What would our common denominator be?
Minus cosine squared.
1 minus cosine squared? Okay, so how'd you get that?
You multiply the others by the reciprocal.
Okay, yeah, so you just multiplied 1 minus cosine beta times 1 plus cosine beta? Yeah. So, do that. That would be how you get your common denominator, and then finish off this problem on your own. So it looks like almost everyone's there. Could someone run me through, once they had multiplied and gotten common denominators, what'd you get in the numerator? You got 2? Okay, so how'd you get 2? So you had 1 plus cosine b, or cosine beta, plus 1 minus cosine beta. Cosine, cosine cancels, and you're just left with 2. So, two over, and then when you FOIL that, you get 1 cosine squared beta. Is that right? Okay, how do you simplify from there? It's like maybe 2 more steps.
1 minus cosine squared beta is equal to sine squared beta.
Okay, 1 over cosine squared is sine squared. So we have 2 over sine squared. And then what's that equal to? Yeah, so we have 2 sine squared, and that's just like 2 times 1 over sine squared. That's the same thing as 2 cosecant squared beta. And if we look at the identity that it wanted us to verify, it wanted us to verify that that was equal to 2 cosecant beta. So, any questions on that one? Something there didn't make sense. Again, the whole idea is really just use the tools that we developed the last 2 days. Factor, use identities when you can. If you're adding fractions, find common denominators, same sorts of stuff. So, another one to verify in your notes. We have secant squared x minus 1 times sine squared x minus 1 equals negative sine squared. Try that one. So on this one, it looks we had a few troubles with this second term. This first term is pretty straightforward. What does that simplify to? Secant squared minus 1. Tangent squared, yeah. So we have tangent squared x times sine squared x minus 1. Now this is tricky. This looks like one of our Pythagorean identities, but it's a little bit different. What's different about it? Yeah, so it's negative. So normally, like when we have sine x squared plus cosine x squared, normally it looks something like this. We have like cosine squared x is equal to 1 minus sine squared x, but the signs are flipped. We have sine squared minus 1, so what do we have to do? We have to make it negative. So instead of subtracting sine squared to the other side, subtract cosine squared from this side, subtract 1 from this side, and we get sine squared x minus 1 equals negative cosine squared. So it's just like the Pythagorean identity, but we subtract it differently. So instead of sine squared x minus 1, what could we replace that with? Yeah, and it'd be our negative cosine squared. So because our order is different, instead of 1 minus sine, we have sine minus 1, so it's just negative. Times negative cosine squared. And then next step, simplify that. Yeah.
Could you just take out a negative 1 for the sine squared x minus 1?
Oh, so here's factor out a negative 1 out front?
Yeah.
Yeah, you could absolutely do that, yeah. And then you just have your normal Pythagorean identities.
Can you do that off to the side? I want the class to see what Everett just said.
Yeah, so what Everett suggested doing was here, because this isn't like our normal trig identity, we just factor out a negative 1. So we write a negative 1 out front, and then we change the sign. So instead of negative 1, we have positive 1. Instead of positive sine squared, we have negative sine squared. So then that just becomes negative 1 times cosine squared, or negative cosine squared. Same thing, different process. Last couple steps to simplify this.
Change tangent, sine over cosine.
Change tangent to sine over cosine. So we'll have sine squared x over cosine squared x times negative cosine squared x. And then that's going to simplify. We can cancel out our cosines. And remember, be careful to not cancel out the negative here. We have negative cosine squared, but positive cosine squared here. So we can only cancel the cosines, not the negative. We're left with negative sine squared x is equal to negative sine squared x. We verified it. Anything there didn't make sense? Questions? Yeah, here.
Can we do it differently? Like, cause I looked at the tangent squared minus cosine of squared. I looked at the ratio identities and sine divided by cosine equals tangent, then tangent times cosine equals sine.
So, explain that to me one more time. What did you do from right here?
Well, if according to the ratio identity, tangent is equal to sine divided by cosine.
Right.
So if tangents times cosine, then it must equal sine. Or
Yeah.
tangents times cosine equals sine.
Yeah, so you basically just skipped a step. You skipped this step right here and went from tan squared times cosine squared straight to sine squared.
Yeah, but you can do that, right? I can.
Yeah, sure. I'd consider that. Yeah, definitely enough. Last one that we're going to go over today is just cosecant minus sine equals cosine x times cotangent. And which side do you want to start on here? Left? Yeah, I would say the left is probably a little bit more complicated than the right. I think you might have a hard time going from a product, cosine times cotangent, to a difference, cosecant minus sine. So I would start with the left side. Yeah.
Yeah, so you can just rewrite cosine squared, which is cosine x cosine. And then you just have cosine.
It's already said in the one second. Makes sense. I'm just trying to see what the other two look like. And I don't know.
How do we come in here? So if we're trying to subtract two fractions, because
The common denominator.
yeah, so when we try getting a common denominator here, and then we can subtract
So you have like
just this.
sine squared
and
cosine.
that's cosine.
Mhm.
Right, yeah, but you knew, so that would be like this term right here. So you'd have how do 1 over sine minus sine squared over sine.
Like people do it just write the answer because they don't know it's supposed to be. They don't use it. So you see this in the just right?
Yeah.
That's the last one. Like, you have to do this, but you do 1 point, 2 points, 3 points, 4 points, and all of a sudden you say that. He's confused because he doesn't know what you
Cosine.
that's me.
And then it's just like, what's this? Okay, so you want this.
Yeah.
Okay.
Because it's telling me
So,
when we, I
where should we
know
start?
this is this, and I know this is this. Yeah, remember you tried
leaving that as sine. It might be easier if you just leave it as sine.
I just wanted to know how you.
So if you're adding or subtracting fractions with sine, yeah, so try to get a common denominator.
I got confused, but I don't know.
Okay, so it's always good to know where you're trying to go. You're trying to go to cosine cotangent. So maybe pick one of these cosines and just kind of put it out. So I have like cosine times cosine over sine. that's good.
You know the
So
common
now we're fine.
denominator.
Yep, common denominator.
This one's already.
Yeah.
So you get your O's.
Well, do you how you multiply fractions again, right? It's be like I'd be times this side, both of these by sign. Right? If that's if that was the way I was doing it.
You would go cosine times cosine, 1 times sine.
Top by top.
Bottom by
bottom. Yeah, thanks.
Okay. So, how did you? I'll see you.
Right, good.
Alright, that's awesome.
So you just remove it.
So I'm looking around, and for the most part, you all had it on your own. And for those of you who don't, I'll just walk around and check with you. Your assignment is 9 through 18. You have about 20 minutes to work. Yeah, so you can get going on your assignment. We'll cover that last slide on Monday.
I'm done. Right.
Really, yeah. So now combine these two.
When you subtract, you just get rid of one. So you want to sine squared x, but you keep that.
Mm-hmm.
So what can you do about that?
This here.
Right, your identities.
Was I doing it right? I wasn't. I was doing it wrong.
So there are always multiple ways to do this.
You think the Pythagorean.
This, I mean, this. So this, this right here.
So where would I go from here?
If you subtracted cosine squared from both sides here, you get sine squared equals 1 minus cosine squared. So it's the same thing. 1 minus sine squared is cosine squared. Cosine squared over. Now, you're trying to get here.
Well, yeah.
How would you rewrite that?
I know you know what you are, because if you.
I was the same thing.
You're at.
This axis.
So, you want to cosine of tangent. Maybe just take one of these cosines and kind of leave it out. Cosine times cosine over sine.
Oh, much better.
Good? It's easy?
Cosine.
Yeah.
Is that right?
Oh, yep.
Yeah, really good. Good job.
So we need cosine. I think it's back where you started.
Oh, yeah, yeah.
Awesome. Nice job.
No, I think the vision looked like the vision was pretty solid. The ones that are faded were all pluses. A lot of the ones in the grouping symbols were all pluses. The divisions, obviously, and the other ones that you, I didn't think were
Alright, I guess
Okay,
that's what
yeah,
I was
sure.
right.
Did you guys do this?
Yes. That's what we got. Spelling everyone was working.
Exactly. So multiply by that top line. You can see how that simplifies.
Yes, people were getting.
Yeah.
Except if we're getting it, so we scroll down.
I don't-
realize that it's going good.
You haven't done it on the board yet.
As long as you
I
do
think he said he did
top
it.
and bottom. Yeah.
Mr. Pagner.
Yeah.
I have questions.
One second.
Take your time.
No, we just gotta finish something. We gotta tell you something quick.
It wasn't me.
And then I have 5-1.
Mr. Painter, it's in this one. The pen?
Oh, is it? Okay. Okay, can I say something to you? I need you to do this. When working a problem, will you just do this, please? Stay organized. Show me your thoughts, what you're doing from step to step to step to step. That side, if you're not going to change it, you can just draw arrows. But can you keep the left side on the left and the right on the right? Because I'm looking at Hannah, and now she's out of class, so I can pick on Hannah. She's out of class. Hannah's went this way. She went like this, and she went like this, and she went like this, and she went like this. And I mean, to follow her work, she knew what she was doing. She was just doing a zigzag all the way down, and it's really hard to follow that, guys. So if you could keep left on left, right on right, that would be appreciated by us. Okay. Then we got here, and Everett. You know what Everett did right here? He said that over that is, and he said it's that. He just said it. He didn't prove it. Do you get what I'm saying? And maybe you don't get what I'm saying, but I am trying to get you to understand you get points for everything you show. So Everett, help the class, tell the class how you knew that was the answer. Okay, so he did this. He took cosine times cosine. This is after I said, Everett, how do you know that's the answer? And then he told me, cosine times cosine over what? Sine. And then he showed me this. He said, this is how I knew that was the answer. So he actually knew it, he just didn't show it. And remember, you got two teachers here who are going to be looking to give you points. 5 points per problem. He lost a point because he didn't show this last step. What is cosine over sine?
Cotangent.
Cotangent. And then times what? Times cosine. That's what it was supposed to equal. Anyways, I'm just trying to tell you, would you please show everything? And would you also keep organized? Straight down, straight down. And I know how hard that is for you horizontal workers. Who are my horizontal workers? I know. It's just very difficult to see what you're doing because you guys keep doing this. You work horizontally and then you go like this. And it's like, where are you going? That's it. I was just trying to get that from 1 second.